Hello, this is the solution video for CS364 PEX 1 in the spring of 2016. For problem number 1, we were supposed to create a soaring database. That database was supposed to track two entities, pilots and maneuvers. We have several attributes for pilots. We have several attributes for maneuvers. All attributes are supposed to have values. In other words, they are supposed to not be null. We have a one-to-many relationship from the pilots to the maneuvers. And no pilot should be deleted out of the database until all maneuvers belonging to that pilot are manually deleted first. And if a pilot changes his ID, then that pilot ID needs to be updated appropriately in the maneuvers table. An example here provided. So let's create our database. First, we'll start by creating a pilot table. We see that the pilot ID is a character of length 3. We'll set that as the primary key. We also have a pilot last name, and we'll use a varchar for that. Make it nice and long. We'll set that as a not null attribute, and then a pilot phone. And we'll make that a char of length 10. We don't want to use an integer. We don't plan to do mathematical operations on the phone numbers, so we'll just list it as a string of length 10. And let's create the maneuver table. Maneuver ID will also be a char, but this will be a length 4. That'll be the primary key. Now, although the pilot's name is listed here, what we really want is to link these two tables. And the maneuver table has to have a foreign key in it that is the primary key of the pilot's table. So we need to put the pilot ID in the maneuvers table. So that's what we'll do right here. And the data type has to match the primary key in the pilot table. So we'll say that this is not null, no value could be null, but this references the pilot table, pilot ID. And we're going to add some attributes there, but we'll come back to that in a moment. Maneuver name, allow for nice long names. Maneuver grade, we should add some more space here. That'll be a character of length 1, also not null. And then finally the maneuver date. Now something we mentioned up here with the foreign key is that the pilot cannot be deleted out of the database. So on delete, restrict. And then the other one is if a pilot changes his pilot ID, we want that change to be reflected in the maneuvers table. So on update cascade. And that is basically our database with appropriate relationships. Another way that you could have done this, just changing the way that we defined our primary key. You could have maybe said not null, unique, although that's not technically required. If you come down here and you say primary key, pilot ID. So this is another way of setting the primary key of the pilot table. We can do the same thing in the maneuver table. So we set the primary key of the maneuver table, and then if we were to set the foreign key, we could do the same thing. Foreign key would be the pilot ID, which references Just add all that back in here. So this method and this method are completely equivalent. You can choose either one. This one required a little bit more typing, so if I were doing it, I would probably use this approach here. It maybe isn't quite as clear where you define your primary keys at the bottom, so there's certainly an advantage to doing this. You just knock out all your attributes and then you define your primary key and your foreign keys at the end. Either way is up to you. Let's add some data to our database. We'll start with our pilot table. So because pilot ID is a string, we're going to, or a char of length 3, we will encapsulate it or enclose it inside of quotations. If those were integers, we would not put, if the data type was of some sort of int, we would not put it inside of quotations. Got an error right here. And we don't need that. And we'll insert into the maneuver table. For our pilot, we have Doolittle, which corresponds with the pilot ID of 002. And remember, for a SQL date, we do year, month, day. For Doolittle, that is, or for Jaeger rather, Jaeger is pilot ID 001, who performed a wing over. And the last maneuver, 003, Earhart, pilot ID 003, and a wing over. So perhaps we should test out our database here. We'll run these commands so that we can set up our database. Let's create our tables. By highlighting and then clicking on that first lightning bolt, I execute only the things that are underneath the light highlighted. If I put my cursor on a command and then execute this one, that executes just the one command. So down here, maybe I can take a look at both of my tables. Just to make sure that the data looks correct. There's our pilot. You can double check that that corresponds to the correct information in both instances, and let's run the maneuver table. And that information also looks correct. We got Doodle 002, Jaeger 001, and Earhart 003. All right, we'll leave those there in case we need to use them again. So we need to update our maneuver table. The maneuvers will no longer be graded. Essentially, we're just going to give the pilots a P for performed. So we want to set the maneuver grade to P wherever the maneuver name was wing over. So we saw the database here. We've got A and B. If I execute this, we'd expect these to change to P. So execute that, and then we'll run the maneuver selection again, and there we are. We've changed the grades to P. Next, we need to remove all maneuvers performed before the year 2015. So let's delete from maneuver where, and you have a couple of options here at this point. We could do maneuver date is less than 2015, so this would be the first day of 2015. You could do it that way, or you could do delete from maneuver where year maneuver date is less than 2015. So we'll use a number here since we're actually doing a numerical operation here. So I'll run this version, and then we can select star from maneuver, and we see that we have deleted that middle value here. We've deleted this row from our database. So either one of these two options would be okay, and there's probably others you could use. You could do less than or equal to the last day of 2014. And then finally, we're supposed to show all attributes for all pilots. Very good. Verify that that works. Now we're going to use the Sakilla database. Moving on, this is the database that we're using. It may be helpful at this point if you had a version of this out as you follow along, some sort of hard copy of that. So what we want to do here is we want to write a query to get the customer ID, staff ID, rental ID, and payment date, as well as the amount for all payments greater than $8. One of the first things I do, rather than trying to figure out what I want to project, I'll just do a select star, and I'll worry about joining the tables. So we want the customer table. We'll take a look and see how they're joined. We got the customer table joined to rental, and then rental is joined to the staff table as well as to the payment table. Now, if we look closely at the payment table, it actually turns out that the payment table has the payment ID, the customer ID, the staff ID, and the rental ID, the payment date, and the amount. So we technically don't even need to join all these tables. So let's take a look at that. Select star from payment. We could say where amount is greater than 8. And okay, again, we've got dates here, so we could say payment date is greater than or equal to, again, year, month, day. July is the 7th month. And the last day would be the 31st. So let's just run this and see if we get something similar to what we're looking for. So we wanted the customer ID, we wanted the staff ID and the rental ID. We wanted the payment date, and we wanted the amount. We want all the amounts greater than $8. Let's see, the smallest amount we have is $8.99, so we met that criteria. The payment dates that we have, the smallest one is July 5th, the latest one is August 23rd, so everything that we have here meets our criteria. We have 673 records. It said 673. Looks like we need to order them by payment date. We'll just assume, without any other guidance, that that needed to be in ascending order. So instead of selecting every field, let's select the fields in the order requested. So here we are selecting just everything from the particular values from the payment table. Run this one more time and verify it's what we expected to get. We are sorted by payment date in increasing order. We've got an amount, customer ID, staff ID, and rental ID. You could take this same problem here and you could do dates a couple of different ways. We could do, say, month of payment date equals 7, or month of payment date equals 8, and we say year of payment date equals 2015, and so we want this payment date is 2005 rather, and then either of these. So I'll put those inside of parentheses here just to insist on a proper order of operations. Otherwise it would operate from left to right. So we've got year 2005 and either of these 2 months, month 7 or month 8. These two would be equivalent. Let me just run this one and verify. Sure enough, 673 rows are returned. So you'd be free for problem number 4 to do either approach or another if you had discovered that and it works. So I believe that one's done. Now we're going to write a query to get the first and last name of each customer who has not rented a video. So this is interesting. Essentially, we're looking for customers that have never rented a video. Rental has a customer ID in it, and customer has a customer ID. So essentially, we're looking for a customer ID that does not appear in the rental table. So there's a couple of ways to do this. One way would be we'll just do a select star again and not worry about. We'll select star from customer where customer ID not in. What we want is some sort of list. We want the list of customer IDs from the rental database. So we could do this with a subquery. Select customer ID from rental. So if we run this, we will get Brian Williams, which is what we expected to get. Now let's just project only the first and last name. So that was one approach. I think it's the simpler approach, but another way that you could do this is to actually join these tables. Now if we join the table, the individual that we're looking for, if we do a normal inner join of some sort, the individual that we're looking for that never made a rental, he'll drop out. He will not be in the result set. But if we join the customer table to the rental table and we do a left join, then we get all the customers and they'll be paired with meaningful rental information unless they've never rented anything, in which case their rental details will be null. So we can take that approach as well. So we'll select first name and last name, but this time we'll do it from customer, and we'll join that to the rental table with a left join. We'll use the customer ID, and we want to find wherever that rental ID, well, let me just do this result set first. So if we do this, let me get rid of this and we'll do star. So here is every customer paired with their rental information. So we have a bunch of stuff on Mary Smith, and we've got all this rental information. Now, So we can look through this. We know that we're looking for this fellow named Brian Williams. So Brian Williams he has null information for rental detail. So we can filter this result set where rental ID is null. And if we do that, then we'll get the same result set that we had before. We just project the information that we want to project, and we get the same result. So either option, this one or this one, you're free to choose either approach. Problem number 6, we want to report the average number of times that videos beginning with the letter A were rented. We want to name that column name average times rented in our result. So again, we'll just do a select star. What we want to do, we have to join film. Film is the table where the film titles are listed, which is connected to inventory, connected to rental. So we need to join film, inventory, and rental tables. We'll start with film, which we'll call F. We'll join that to inventory, called I, and we will use the film ID. We'll join that to rental using the inventory ID. One thing here is it says each video was rented at least once. There's a bit of a caveat there. There are films in the film database that are not in the inventory. So every film in the inventory has been rented. So if you do this join, you'll have no problems because an inner join between the film and inventory will include only those films that are actually in inventory. But if you try to do something where you were just counting the number of films and then divided by the number of items that were rented, that would have given you problems because there are films not in the inventory. So let's take a look and see what this gives us. This gives us all kinds of information. Academy Dinosaur gives us every single rental event on Academy Dinosaur. Our result set, we don't want to have Academy Dinosaur listed over and over. What we'd like to do is have just a single record for Academy Dinosaur and for every movie. So we're going to group by film ID. Now I think it's a really good idea to, when you do a grouping, to group by a primary key. When you group by a primary key, you're guaranteed that it's unique. If I had done instead, say, group by f.title or something along those lines, it's possible that two movies that are different movies had the same title. So I will do f.filmid, and we will also go ahead and do a count of, say, maybe rental IDs. Well, if you think about it, you could count anything and have the same result. So we're going to count rental IDs when we group by the film ID, and then we will include the rest of the film's information. So we run this. Now it looks like we have a single entry for each video. Academy Dinosaur was rented 23 times, Ace Goldfinger 7, and so forth. And we have the rest of the video information. Let me grab this just to show something here. So instead of the film information, I will bring up the rental information. Here, this is Academy Dinosaur. Now, the question is what rental date is this for the movie Academy Dinosaur? Academy Dinosaur is rented 23 times, but there's only one rental date listed here. Now the fact is, it's some arbitrary rental date. It probably is the first one in the result set, but there's no guarantee of that. So what I'm saying is that when you group by a field and you pull things from another table where it would actually be listed multiple times, this data is pretty much arbitrary and probably should not be used to draw many conclusions. But what we would like to do is we would actually like to take, let me go back so we can see the film names. It'd be nice if we could somehow take the average of all of these counts. So one way that we could do this is actually take this table and we would do a selection on it. So we're going to select average. We maybe give this a name. So this will be our rental count. So we want to select the average of rental count from this table that I'll put inside of inside of parentheses. Those parentheses are required. Now, when you have a subquery like this, it has to have an alias. So I'll call it just temp because we never need to use it again. Now, if I run it, before I run it, I also need to. I only want the letter beginning with the letter A. So before we group, we want to filter. We don't want to count videos or include in our count videos that started with a letter other than A. So where f.title like a %. We run this and we get the expected answer. There's one other way that you could do this. I'll copy and paste this. Well, there's probably several ways, but here's another convenient way. Instead of doing a subquery, we could have created this as a view. Create view, maybe rental counts as this selection here. So creating this view, it basically stores in the database a view that we can query again. So I'm going to create the view. We don't see anything. It just simply says that the view was created. Now I could do a select on that view. And it looks basically the same as our original selection did. Instead of select star, I can do an average of rental count. That is, I'm doing an average of this column here. We run that, and we get the same result. So these two commands here, where we create a view and then we select on that view, or a single command where we essentially, instead of creating an intermediate view, we just treat it as a subquery, either approach would have been a correct approach, and you may have found another still. Before we move on, the thing we need to do to make these problems completely correct is to name this column average times rented. So we'll give each of these columns an alias. And then with this in mind, then we would have our correct answer along with the proper column name. All right, problem number 7. We want to produce a report showing the number of times each actor has acted in each category of film. So we have an actor, Ben Willis, category sports, presumably somewhere in the database there might be Ben Willis, category horror. Here we've got Julie McQueen, horror, maybe she was also in sports films, and so forth. So, and we want to only show those that were in a particular category 6 or more times, and we're going to order them by most times in one category listed first. We want these attributes. So let's take a quick look at our entity relationship diagram. We've got the actor connected to the film actor, connected to the film, connected to the film category, connected to the category. In order to do this, again, we'll do a quick select star, and then we will just join these tables. I'll start with the actor side. To film category. All right, let's go ahead and group by actor ID. When we group by, oh, look at that. When we group by category, or when we group by actor ID, here we have Penelope Guinness, and we see over here we see a category animation. It's inside the name field. So we have this animation. Now, like I mentioned before, when we group by the actor, all the other data that would be pulling from another table where there's a one-to-many relationship, this is just an arbitrary category that's pulled from one of the perhaps many videos that Penelope Guinness has been in. And we don't really want this. In fact, what we want is we want to group by two fields here. We wanted a report showing the number of times each actor has acted in each category of film. So we want to group by actor as well as category. When we do this, it gives every actor for every category. So Penelope Guinness will be listed once for animation, once for action, and so forth. So here she is, Penelope Guinness, along with all the various categories that she could have been involved in. So we have this, we want a count. So again, it doesn't really matter what we count, but we'll just count a film ID. We even see that there's a bit of a hint here that that's what they did. And then maybe we'll get the rest of the actor information. So, or rest of the actor information here. So that's the A, actor.star. All right, so we can filter this. Hopefully we find Ben Willis with 9. Sure enough, Ben Willis, 9. We don't have his category names. We'll have to add that. This Grace Mostel was involved in something. There's no guarantee in terms of the order that you have these after when they're all equal after that, but somewhere there ought to be a Julia McQueen with 7 videos. So let's add the appropriate fields. We want actor first name, actor last name, and then we want C.name, but let's rename that to category. And then we want the count. And we'll go ahead and order by count, film ID, and we want it to be in descending order. So we have the videos, and sure enough, we're starting with 9. After that, with all the 7s, there's no particular order defined. Now the one thing we have here is we have actors who were in videos fewer than six times in a category. So we're going to use a having clause. Now having clause, we have to use a having clause whenever we are using a group by and we want to filter based on the aggregation operation. So this is the aggregation operation here where we counted. So we want to not show every record, but only those records having a count film ID that is greater than or equal to 6. And then when we do this, we get the records that we would expect. Having has to be used when you are wanting to reduce the number of records based on an aggregation criteria. In contrast, you would use where. Where would appear here when you needed it. It would appear before the group by command, and you would use where whenever you wanted to filter your result set before you started your grouping. So I believe that's the end. We've answered problems 1 through 8, or 1 through 7. 8 kind of left to your own, and I look forward to seeing some of the creative things that you may have come up with.